ML-KEM, formerly known as Kyber, was standardized as FIPS 203 in 2024. It is the default post-quantum key encapsulation mechanism for the next generation of TLS. KEM stands for Key Encapsulation Mechanism. It exposes three operations. KeyGen produces a public-private key pair. Encaps takes the public key and produces both a shared secret K and a ciphertext CT that wraps K. Decaps takes the secret key and CT and recovers the same K. K is typically 32 bytes, used as the AES symmetric key. ML-KEM's mathematical foundation is the Module-LWE problem. Given a public matrix A and the value be equal to a times S plus E modulo Q, find the secret vector S. Both S and E have small coefficients, and Q is the modulus 3329. The problem is conjectured hard even for quantum computers. Visually, a lattice is a regular grid of points in space. The secret vector S is a short hidden vector. The error E blurs the public point B away from the lattice. Given a near lattice point, finding the closest lattice point is the closest vector problem, while finding the shortest vector is the SVP, both NP hard in the worst case. ML-KEM-768, security level roughly AES 192, public key 1184 bytes, secret key 2400 bytes, ciphertext 1088 bytes, shared secret 32 bytes. Compared to X25519's 32-byte public key, ML-KEM is about 37 times larger. The 5-step protocol. Alice runs KeyGen to produce a key pair. Alice sends PK to Bob. Bob runs encaps on PK, getting ciphertext CT and key K. Bob sends CT to Alice. Alice runs decaps on SK and CT, recovering the same K. Both parties now share 32 bytes of K, ready to drive AES. Real-world deployments use the hybrid group X25519 ML-KEM-768. The classical X25519 key is concatenated with the post-quantum ML-KEM key through HKDF. As long as one of the two stays secure, the combination is secure. Chrome 124, Cloudflare, AWS, and OpenSSL 3.5 have all enabled this hybrid since 2024. ML-KEM-768 is the default KM for post-quantum TLS. Public key around 1.2 kilobytes, heavier than ECDH but acceptable. Up next, MLDSA, digital signatures built on the same lattice foundation.